Okay, in this video I'm going to go over a little bit of 7.1 and then we're going to do the notes for 7.2. So I put this picture back up again. This is from page 1 in your notes, and it's highlighting the Pythagorean triples. So the key is, if you look at a right triangle and you see that you have sides of 3, 4, and 5, that's a Pythagorean triple. So what if I ask you about another triangle? What if I say, I'm going to build off of this one. What if I say, here's a right triangle, and this side is 6, and this side is 8, and I want to know this side. Well, if you look at that and you say, wait, that's just a multiple of 3, 4, 5, because 3 times 2 is 6, and, 2 times 3 is 6, and 2 times 4 is 8. So this side, this missing side, must be 10. And sure enough, that's a triple. Okay? So knowing your triples saves you some work. Let's try another one. What if I say I have the following? I have 51, I have 45, and I have x. Now, I can run through the whole Pythagorean theorem, or look, I can look at this triple, 8, 15, and 17, and if I multiply each of those by 3, look what I get, 24, 45, 51, so then I know that x is 24. So just saying that it's nice to know some of the triples. You don't have to know them all, but if you can save yourself a little time occasionally, that's a good thing. Okay, let's go on to the next page. Okay, so I wanted to go over this because your homework assignment was a graded homework assignment, and it was graded for accuracy, and I asked you to use Pythagorean theorem and to also simplify things using your rules with radicals, and you had to find the area. So I'm going to show you 2 examples of what I would mean by that. Okay, so this is also in your notes. You can probably find this page. I got rid of all the other parts of this, and let me just tell you exactly where it is. So this is on page number 5. So this is page 5 in your notes, and I do not believe we did this page. So I'm going to do this. I'm going to find 2 things. First, I'm going to find the unknown leg length, and then I'm going to find the area of the triangle. Okay, so I'm asking you to do 2 things. So I'm going to do them with you right now. Okay, so you know that the largest side is the hypotenuse, and that's called the C side traditionally. So C squared equals A squared is a leg plus B squared. This is a right triangle, so I know that this equation will hold. So 15 is the largest side because it is opposite the right triangle. So 15 squared equals, let's take the 9 as the A side, plus some mystery x squared. So what I'm going to do is I'm going to say, does that look like a triple? So I have a 9 and a 15. So let me look back for a second and see. 9 and a 15. Oh, look at that. 9 and 15. I bet the other leg is 12. So let's go back to what we're working on. So I'm going to guess x is 12, but I'm going to work it out just so I can demonstrate why that is going to be the case. Okay, so 15 squared is 225 equals 81 plus x squared. So 225 minus 81 equals x squared, and 225 minus 81 is 144. That equals x squared. Now I don't want x, I want the square root of x. I just want plain old x. So take the square root of both sides, and x is going to be 12. Okay, let's figure out how I got that square root. So we'll do another little work here. What if I didn't know that 144 was a perfect square? What could I have done? Here's my 144, and I see it's an even number. So that's going to be 2 times 72. Okay? And then 72 is also divisible by 2. So I can break this up into 2 times 36. That makes 72. Keep going. And I'm going to break up 36 into 6 times 6. When I get to that point, look what I have. I have my double. Circle a double. Pull it out as a 2. Circle a double. Pull it out as a single, as a 6. And that equals 12. So whether I find the 12 by simplifying my radical, by knowing that 144 is a perfect square, or by knowing my triples, in any event, I'm going to get 12 for that missing side. Okay, I'm going to go back up now and find the area. Okay, on top of that homework sheet, I said area equals 1/2 base times height. So 1/2, the base is going to be the x, the 12 side, we just solved for, and the height is the 9. So what I can do is I can divide 2 into itself, divide 2 into 6, and then 6 times 9 is 54. Let's just say that this was in inches. The area would be in inches squared. Okay, so that's a little review of finding a missing side and then using that information to find your area. I would like to talk a little bit about this isosceles triangle at the bottom. And in order to do that, I think what I'm going to do is erase this so I have a little bit more room to work. And I will also change my color for you. Okay, so you can see I had other things under here. So let me just color that back in. And now we're good. Okay, so I see they want me to find the area of the isosceles triangle. I know, and I'm going to change color. I know that area equals 1/2 base times height. The height of the triangle is this right here, but I don't have that. So when you drop that height is called an altitude. When you drop it, you divide the base into 2 equal parts. That h is a perpendicular bisector. It comes out of the vertex, cuts the side opposite it, excuse me, in 2 equal sides, and that means I can make them both 8, and that right angle's formed. All those things are what an altitude does. Okay, so I need to figure out the height. So I'm going to come up here, and I'm going to take half of the triangle. This is an 8. This is the missing height. That's your right angle. And this is a 10. So what do I know? I know it's a right triangle, and I know that c squared is going to equal a squared plus b squared. In this situation, the c is the biggest side, as it always is. It's the 10. Let's use this 8 down here, plus another value, which we're going to call b squared, which maybe what I should do is call it the height squared. Would that make more sense for you? So we'll make that height squared, because that's what I'm really looking for. Okay, so this is 100. This is 64. This is h squared. So 100 minus 64 equals h squared. That is 36. That equals h squared. Square root, square root. The square root of 36 is 6. That's my height. Okay, so now, and by the way, guess what? 6, 8, and 10 is a triple. Should we go back and see? 6, 8, and 10, right here, it's a triple. If I knew that, I would have not had to do all the math. But there's always a way to get your answer by using math, but the triples are nice to know. Okay, getting back to finding our area. Area equals 1/2. Now the base of this triangle is the entire piece, not half of it, the entire piece. So that's back to 16, and the height we discovered was 6. Okay, 2 goes into 16 8 times, and 8 times 6 is 48, and this was inches, so that's inches squared. And we are done. That's the area of that triangle. Okay, so that was just some review stuff. Let's now get into the notes on the next page. We'll go into the 7.2 notes. Okay, so here they are. Starting 7.2, it's using the converse of the Pythagorean theorem. We have two vocab words first. So the first one says an acute triangle. We know that from previous lessons. An acute triangle is a triangle that has three acute angles. And remember, acute angles are less than 90. That's an example of a acute triangle. Okay, so acute is less than 90-degree angles. Okay, an obtuse triangle is the other extreme. It's a triangle with one angle greater than 90 degrees. So this could look like an obtuse triangle. Okay, let me say that this angle, make this 92 degrees. That makes that an obtuse triangle. Okay, in this little box to the right, it says, how do I know if my three side lengths will make a triangle? So this is the 5.5 material. So remember what we had to do was say any two sides added together has to be greater than the third side. And right away we say that this does not work because look, 3 plus 4 is 7, and 7 is certainly not greater than 7. Would the other ones have worked? So if I said 3 plus 7, is that greater than 4? Yes, that checks. And 4 plus 7, is that greater than 3? That checks. But because you had one combination that did not check, this cannot be a triangle. Now, you might think it's odd that I'm mentioning this now since it's a 5.5 material, but we're going to revisit this because we're going to tell what kind of triangles we have, whether we have acute or obtuse triangles. And before we know what kind of triangle we have, we want to verify that we can actually make a triangle. So that's coming in just a second. Okay, so the converse of Pythagorean theorem, it's just that you read that backwards. So the converse would state, if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So the regular Pythagorean theorem said that if the square of the legs of the two sides equaled the square of the hypotenuse, then you had a right triangle. So they just read it backwards. That's what converse is. Okay, in here I have a video embedded. So if you open up your notes packet and you can cut and paste this into your browser, it will show you a video on YouTube about Pythagorean theorem. So let's keep going. Okay, we're going to talk about acute triangles and obtuse triangles. And there's one word I need you to cross out here, so I'll tell you that in just a second. Okay, if the square of the length of the longest side of a triangle is less than, so that's our less than symbol, so it's less than the sum of the squares of the lengths of the other two sides, then the right triangle is, or then the triangle, so get rid of the word right. Then the triangle is an acute triangle. So I had written this for you. I think we're going to do it this way instead. So here's our situation. C squared, A squared plus B squared. If I find that the square of the length of the longest side, which is the C side, is less than A squared plus B squared, that is an acute triangle. So how can I help myself to remember this? If you think of this less than symbol looking like a little bit of an arrow, look what you're pointing towards. You're pointing towards the C, and what triangle has a C in it? The acute one does. So when you are pointing towards the C, it's going to be an acute triangle. Let's do the next one and see if this starts making sense. If the square of the length of the longest side, okay, that's the square of the length of the longest side, is greater than, okay, so this is the greater than symbol, then the sum of the squares of the lengths of the other two sides is what? So if it's not going to be acute, it must be an obtuse triangle, and this is the way that's going. Okay, so look at that arrow again. Think about this as being an arrow. What letter are you pointing towards? Not the C, but the B. And what letter appears in obtuse? The B. So that's just a little trick that you can use to remind yourself about this definition. And then don't forget that if C squared equals A squared plus B squared, what kind of triangle do we have then? We have a right triangle. Okay, so make sure up here you have eliminated that word right. Okay, let's go on to the next page, because then we'll start practicing some of this, and once we start applying it, I think it will help make sense of it. Okay, so let me go back for 1 second. Okay, so I think I have to add another page in here. So let me do, no, actually I'm fine. I'm fine, never mind. So here we go. Example 1, verify right triangles. Tell whether the given triangle is an acute, an obtuse, or a right. Now, don't go by looks. Look at what we have here. We have 3 sides. I know that the equation I'm going to use is going to be C squared. I'm not sure if it's going to be greater than, equal to, or less than. And then I'm going to have A squared plus B squared here. Okay, so remember, you have to have the largest side be the C squared. When I have a radical in my side lengths right here, it's hard to tell what side's the largest. So go ahead and square them. 9 squared is 81. 15 squared is 225. Okay, 3 root 34. How do we square that? First you square the 3. 3 times 3 is 9. Then you square the radical 34. Radical 34 squared is plain old 34. Squaring it loses the radical. So what is 9 times 34? Well, 9 times 4 is 36, but then the 6 carry the 3. 9 times 3 is 27, and 3 more is 306. So look, the 306 is the biggest side. So the 306 is the C squared. 306, and now we're going to compare it to 81 plus 225. Okay, if we add 81 and 225 together, guess what? We get 306. That means that these two are equal. And what kind of triangle do I have? I have a right triangle. So this indeed was a right angle. Okay, so look at the next one. Here I can see all my numbers, and I know their relative sizes, and I know I have to figure out C squared and then A squared plus B squared, and I'm not sure if I'm going to have greater than, less than, or equal to, so I'm going to put a little question mark there. Take your biggest side, that would be 26, square it. Take your next side, 22 squared, plus 14 squared. Okay, 26 squared is 676. 22 squared is 484. And 14 squared is 196. Add 484 and 196, and I get 680. This is 676. So 676 is less than 680. Okay, so less than. So think about that arrow. Where is that arrow pointing? It's pointing this way. So go all the way up. There you go. If it's less than, it's pointing towards the C, and therefore I have an acute triangle. Okay, so we're starting to make sense with that arrow, I'm hoping. Now remember, since this is a video, you can stop it, rewind, and start at any point so that you understand. So even if you think maybe I'm talking too quickly, you can still rewind it and play it again so that you can process it at the speed that you want to process it at. Okay, and I'll be none the wiser, but you'll have a better handle on the material if you do that. Okay, so now, example 3. The first question they're asking us is, can segments with lengths of 4, 5, and 6 feet form a triangle? So that's our first job. So let me change my color. So, what do? The segments are 4, 5, and 6. So, 4 plus 5 has to be greater than 6. That works. 5 plus 6 has to be greater than 4. That works. And the last one is 4 plus 6 has to be greater than 5. And that works also. So, what I can say is yes, this can be a triangle. Okay, so then our next question is here. If so, would the triangle be acute, right, or obtuse? So here's my second question. So for the second question, I'm going to use c squared, question mark, a squared plus b squared. My c side is always the biggest side, so 6 squared. My a can be the 4 squared. My b can be the 5 squared. Remember, they're interchangeable. 6 squared is 36. 4 squared is 16. 5 squared is 25. Add those together. That's 1, 2, 3, 41. And 36. 36 is less than 41. So you can put lesses the whole way up. And look, when you get up here, you are pointing towards the C. So therefore, you must have an acute triangle. Okay? So we're going to do one more just like this on the next page. Okay, here are the segments. Changing colors again. Okay, so this says, can segments with lengths 3, 6, and 4 form a triangle? That's our first question. If so, would it be acute, right, or obtuse? So you first have to figure out if 3, 6, and 4 work. So, is 3 plus 6 greater than 4? That checks. Is 6 plus 4 greater than 3? That checks. Is 3 plus 4 greater than 6? And yes, that checks as well. So you can say yes, they can form a triangle. All right, so now we're ready for our next question. If so, would the triangle be acute, right, or obtuse? C squared, question marks, a squared plus b squared. The c is always the biggest side, so that's 6. 6 squared, and then I'll do 3 squared plus 4 squared. Okay, 6 squared is 36. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. So we're going to compare 36 with 25. And 36 is greater than 25. So you can make all these blank spaces greater than. And look where the arrow is pointing. It is pointing towards the B, so therefore that will be an obtuse triangle. Okay, I think we have a couple more problems for extra practice on page 8. We're going to do those now. So this is page 8. This is the extra practice. I kind of cut off the top of this. It said, tell whether the given triangle is acute, obtuse, or right. We don't need to test that they're triangles because we can see that they made them as triangles. So we can assume that, yes, triangles do work. So look at your biggest side. That will be your C squared. That's going to be 23 squared. And then remember, we don't know what this relationship is going to be. And then we'll do 11 squared plus 20 squared. Okay, 23 squared is 529. 11 squared is 121. And 20 squared is 400. Adding 400 and 121, I get 521. I'm comparing this to 529. And 529 is greater than 521. Come on up, put the greater than symbols. Even here, and what do I know? My arrow is pointing towards the B, so this is obtuse. Okay, one more. Okay, so this one has 2 root 41. So I'm going to go ahead up here and just square everything. So this is 64, this is 100, and this is 4, because 2 squared is 4, and then times 41. So that is what? 164. So now I know that 2 root 41 is the biggest side. So here we go. C squared equals A squared. Oh, sorry. I don't want an equals in there. I want to have a question mark there. A squared plus B squared. Okay, the C squared is now, I know it's 164. The A squared is 100. The B squared is 64. Oh, look. They are exactly equal. If they are exactly equal, what do I know? I have a right triangle. Okay, we have got one more of these examples. So can segments with lengths 11, 6, and 7 form a right triangle? That is our first question. So what do I know? It's 11, 6, and 7. So is 11 plus 6 greater than 7? Yes, it is. That checks. Is 6 plus 7 greater than 11? Yes, it is. That checks. What about 11 plus 7? Is that greater than 6? It is. It checks. So you can say yes, it can be a triangle. So now the second question, because that was just our first question, the second question says, if so, would the triangle be acute, right, or obtuse? Here's our trusty equation, question mark, A squared plus B squared. So my biggest side is the 11. So I'm going to say 11 squared. Then I have 6 squared plus 7 squared. 11 squared is 121. 6 squared is 36 plus 49. 36 plus 49 is going to be 85. How does 85 compare to 121? 121 is greater than 85. Fill all these in as greater. And when you get up to the original equation, which direction are you pointing? We're pointing towards the B. And this triangle is obtuse. Okay, so that finishes the notes. Let's just preview the homework. So you should fill in these notes in your own packet. Don't just listen to it. If you have just listened to the whole thing, that's great. Now go back and listen to be able to fill in. It'll make much more sense if you have it written down. Okay, your homework is going to be to do this page, which is page 9 in your packet. Okay, so let's preview this. Tell whether the triangle is a right triangle. So what will you do? You're going to do c squared question mark a squared plus b squared. If you find that c squared equals a squared plus b squared, then you have a right triangle. Okay, but you've got to do the work for all three. Okay, then the next one says, decide whether the numbers can represent the side lengths of a triangle. So you've got two questions. Decide on this, and then if they can, then you're going to tell me what kind of triangle it is. So going back, that is just like this. So don't skip any steps. First decide whether that's going to make it as a triangle. Do it the same way I just did. I did all these little additions to check it out, and they all had to work. You do the same thing. Then once you do that, then you back up to your equation, and you're going to figure out what kind of triangles they are. Remember, if you end up saying 6 squared is greater than a squared plus b squared, that's obtuse because you're pointing towards the b, and the b is in obtuse. If instead you find that c squared is less than a squared plus b squared, you are pointing towards the c, and you have an acute triangle. If you find that c squared equals a squared plus b squared, then that is a right triangle. Okay? So that's what you're going to do for, let me see, for 4, 5, 6, keep going, and 7 and 8. Those are all the same kind of questions. Then you have 2 multiple choice questions here. So here's one. What type of triangle has side lengths of 4, 4, and 4? So answer that. And then the next one is, what type of triangle has 2 of the 3 angles with measurements of 24 and 105? Okay? So, and that's the homework then. So post this before the start of next class. And that ends this video.